Are blockchains and artificial intelligence a match made in heaven? Or the crypto people who push this narrative are just selling empty hype? To answer this, I've read every report and thought piece published in the past year about the AI and blockchain intersection. And I've distilled all that information into the list of the top 14 use cases for the confluence between AI, crypto, and Web3. And for each of them, I've also included the criticisms of the skeptics. Hello, I'm Matt Garcia and I write books and tweets about AI and Web3. To make this video, I've gone through pretty much every author that has been writing about the AI and blockchain intersection, like Vitalik, Ilya, Sami Kassab, but I particularly would like to thank Casey Caruso because she wrote a report with a thesis-antithesis approach that inspired me a lot for this video. Today's subject is very important because if it were true that the blockchain and AI intersection is really something substantial, then this intersection would be a great way for investors to get exposure to AI startups with big upside. Because unlike normal AI startups that are limited to accredited investors, anyone can invest in crypto AI startups thanks to their public tokens. So let's analyze each of these 14 intersections to see if there's something real behind the hype. By the way, I've listed them in order with the use cases at the beginning closer to being fully realized, and then getting more and more speculative towards the end. Okay, so let's get started. Number 1. Crypto Amplifier. The first way in which blockchain and AI are already intersecting is quite obvious. It is AI acting as an amplifier of the entire blockchain sector. And this is happening because AI is the everything amplifier. I call AI the meta invention because for the first time we've invented a way to create more of the very thing that makes inventions possible in the first place. Intelligence. In that sense, this synthetic form of intelligence that we call AI directly amplifies every other sector, because every single economic sector uses intelligence at its core, in the form of employees' brains. And so all the intelligent processes that those humans make can be amplified or even potentially replaced with AI and robotics. Crypto is no exception, and being a code-centric sector, it is already profiting from generative AI, which is very helpful for writing code. But code is just one example. Every other job in crypto is already being amplified or will be very soon amplified by AI. AI-boosted security auditing, automated customer support, creation of marketing materials with generative AI, etc. Antithesis. It's hard to find an antithesis for this use case because this one is already well underway and growing by the day. If anything, we could mention a drawback more than an antithesis. As AI approaches human-level intelligence, virtually every single job will be potentially replaceable by AGI agents and AGI androids. But this is more of an ethical concern than a technical obstacle. Number 2, data for AI. The second use case is again mostly unidirectional, but this time in the opposite direction, with the flow of benefits mainly going from blockchain to AI. Blockchain can provide high-quality data for AI training and inference. AI is a technology that gobbles up data, the more the better. Training relies on data, obviously, but also inference more and more relies on data as the chatbot or soon the autonomous agent can perform external searches to supplement its internal knowledge. Now, blockchain data is a very special type of data that can be very valuable for allowing AI to provide great answers. In particular, the data stored on blockchains is considered to be high quality because the nature of the blockchain makes it unforgeable and verifiable. And even better, the majority of the important blockchains like Bitcoin, Ethereum, and Solana are completely public access. Anyone can access every piece of data eternally and immutably stored in these blockchains since the day they were created, and they can access it for free and without permission. Antithesis. Even if blockchain data is extremely reliable, the majority of the data available on blockchains is just financial and of a very specific niche within finance, transactions between participants in the blockchain ecosystem itself. So its used to train AI or to have AI use it to answer queries is just limited to that specific subject matter. Number 3, agent money. 2023 was the year of the AI chatbot. 2024 is on its way to become the year of the autonomous AI agent. AI agents, unlike chatbots, are not genies trapped in a bottle. You can let them use your computer and browser to do stuff on your behalf. This includes tasks that require money, like making purchases and investments for you, hiring people, etc. For this type of money requiring tasks, many people think that crypto will be the AI agent's money of choice. There are 4 reasons why cryptocurrencies could be favored by AI agents. 1. Crypto is permissionless, which means that any human or any bot can open an account called a wallet and start transacting with crypto. Traditional institutions often ask you for ID and paperwork to open accounts or use their financial products. None of this is necessary in crypto. 2. Crypto is borderless. Another thing that doesn't exist on the blockchain is borders. Transacting with people in the other side of the world is as easy, free, and fast as it is with someone in your own country. 3. Crypto is programmable. Transactions on the blockchain can be infinitely customized via smart contracts. The thing is that for the majority of humans, writing the code of smart contracts is out of reach, but AI agents are perfectly comfortable with code. 4. No psychological barriers. Even if crypto money has all these advantages, it also has many psychological barriers to entry, like fear of the new and a very annoying learning curve. AI agents don't experience these kinds of psychological barriers and will simply use whatever money offers more advantages to them. Also, all the above not only applies to crypto money, but also to crypto finance. Decentralized finance is a whole ecosystem of financial products that don't require any kind of identification or paperwork. Any human or machine can use them to invest in all sorts of conservative or exotic ways. Antithesis. One common misconception about AI agents is that they will be some sort of app that will only be able to interact with other apps via APIs. But in reality, AI agents will soon have almost perfect computer vision. That is, they will be able to use any app that you use, just like you do, by looking at the screen and moving the cursor. This means that your agent will be able to use any app that you want them to use, including your traditional bank account, your stock market account, etc. It is true that an AI agent can KYC to open a new, for example, bank account, but once you have opened one, you can let your agent use it just as if it were you. So that repeated mantra, AI agents will have to use crypto because they can't KYC, gets somewhat weakened by this. So in the end, it is possible that AI agents will do like humans do, use traditional money for many things and crypto for many other things. Number 4, agent cooperation. And speaking of agents, they will also frequently have to cooperate with each other. Hire another agent, conduct commerce with another agent, etc. And once again, the blockchain is one of the platforms that could be a medium of choice for agents to do this. Why? For the same reason as before. It's completely permissionless to use. No red tape, no gatekeepers. And also the interactions on it are infinitely customizable, programmable. And that programmable aspect is crucial for complex agent interactions. By coding their own smart contract agreements, 2 or more agents can clearly establish the terms of their agreement and who gets what out of it in a way that is completely transparent to all the parties and automatically enforced. They don't need to trust each other. If the conditions are met, the contract will self-execute on the blockchain. One example, you task your agent with finding a great logo designer and tell it your budget is $2,000. Your agent does research and finds the best logo designer within that budget, who is also represented by another AI agent. The 2 agents negotiate the terms and hire a third agent, an arbitration agent with a great reputation score and visual judgment capabilities, in case the 2 parties don't agree on the quality of the logo. Agent 1 will transfer the money to the escrow of the smart contract. Agent 2 will liaise with its human to create the logo. And when all is good, the arbitration agent signs its approval and the smart contract releases the money to Agent 2's wallet. Antithesis. Platforms that allow agent-to-agent interaction and drafting of code contracts will be created soon and don't need to run on the blockchain. Antithesis. True, but the blockchain already exists. It's tried and tested, it's permissionless, it's borderless, has its own permissionless and borderless built-in money, is ultra-secure and ultra-transparent. AI agents will use the best product. And so far it looks like the best product for AI agent programmable cooperation is the blockchain. Number 5, decentralized compute. In the 20th century, wars were fought over oil. It seems that in the 21st century, wars may be fought over computing resources. Compute is one of the major bottlenecks for AI expansion, and it's not something in the future. We are already experiencing shortages of the most powerful GPU chips offered by cloud computing providers or in direct purchase. In fact, needs are growing so fast that Sam Altman made it to the headlines recently with his $7 trillion fundraiser to create all the compute that the coming AI world needs. In this context of compute scarcity, a large number of projects to share computer resources are popping up. The logic is to do for compute what Airbnb did for homes. Rent it out when you are not using it. On all these compute share platforms, crypto is being used as the coordination and incentivization layer, with payments flowing from the participants who need compute towards those who lent out their idle GPUs. Antithesis. The most common objection is that distributed computing is not technically capable of supporting some of the most demanding AI compute tasks. This is true in some cases, and it is important to differentiate between inference and training. Training AI often requires lower latency and tighter communication between the computing nodes. And for now, most of those networks cannot offer those specs. But inferences, which means asking questions of the AI, are much more manageable tasks, and distributed systems are much better suited for it. Another objection often mentioned is that precisely because of their scarcity and high demand, there are not that many idle GPUs at any given time available to create a large enough pool of resources to make these services really attractive, especially for the most in-demand and advanced GPU chips. Number 6. Fighting fake humans. In a few years or perhaps months, it won't be possible to tell apart a real human from a human impersonating AI. There's two reasons for this. One, text, voice, image, and video generation will make AI impersonating bots able to write, speak, and look 100% human. Two, cognitive bot detection methods like CAPTCHA puzzles will not be useful because AI will have enough intelligence to solve even the most complex of them. This will force social media companies and other bot vulnerable companies to implement a system to tell apart humans from machines with 100% certainty. This technology already exists and is known as proof of humanness. It involves the most unique part of a human, the iris, sophisticated hardware that can tell if the iris presented to it belongs to a human and a live individual during the initial creation of the proof, and then frequent regular rechecks with something that we all have on our devices, like for example the face scan of your iPhone. The specific of why these proofs work and cannot be forged by AI are far too complex to include here today. But if you are interested, I will make a video just about proof of humanness and why it is so forgery resistant. Now, what does proof of humanness have to do with the blockchain? The blockchain, for its security, decentralization, and privacy preserving adjacent technologies like ZKs, offers the best platform to create the critical infrastructure that can support proof of humanness. In fact, the leading proof of humanness project right now has been built on the blockchain by none other than Mr. Sam Altman himself. The project is called World ID, and already 3.5 million people have created their proof of humanness with it. Antithesis. Before a public blockchain-based protocol like World ID gets enough adoption, the big tech giants like Google and Apple will create some type of proprietary proof of humanness system themselves. I think that's a very valid objection. Proof of humanness is going to be needed so soon to avoid chaos on social media that if the blockchain solution doesn't become a standard very quickly, the big tech giants will create their own proprietary standard. That said, Sam Altman is right now the best connected man in tech. If someone can make Web2 corporations accept a Web3 standard, Altman is probably that person. Number 7. Fighting Deepfakes. All the reports I've read discussing deepfakes talk about them as if they were one homogeneous type of problem. But in reality, if you analyze the issue carefully, you'll realize that we are facing two very different families of problems that require different solutions. The first flavor of deepfakes is media in which the participant is voluntarily recorded. For example, a video of Joe Biden looking at the camera and saying, "Americans, we must get ready for World War III with Russia." The blockchain could offer a solution to this first flavor of deepfakes via crypto signatures and attestations. It is easy to envision a very near future in which we will never pay attention to any video of someone stating something shocking unless it has a badge next to it saying that the person in that video has indeed signed it. Flavor 2 is a completely different animal. It is videos in which people are caught doing or saying something they didn't want people to know about. Like, for example, Joe Biden caught by a hot mic saying to an advisor, "We must keep an eye on Hillary, that wants my seat." The authenticity of this second type can't be decided with a crypto signature because the person in it will never have an interest in signing it to prove it's true. This second flavor also encompasses all those videos of events that people and institutions want to keep secret, like footage of war crimes. Flavor 2 also includes footage of hard-to-believe achievements like some shocking acrobatic or record breakings. Also footage of alleged paranormal or extraterrestrial phenomena. In all these cases, the deepfake problem can't be fixed with someone's crypto signature. So far, I haven't heard of any compelling technological solutions for the flavor 2 of deepfakes. Some people think that we will need to develop some reputation-based systems in which we will trust that some video is true because whoever filmed it has a good reputation score. Antithesis. Digital signatures to state that you are really the person saying something on a video don't require a blockchain, and before the blockchain can come up with a standard and get traditional social media sites adopted, the social media platforms will create some proprietary system themselves. I agree that this is very likely. The only chance that a public blockchain standard gets developed before big tech comes up with its own solution is composability. For example, if something like blockchain-based proof of humanness gets adopted outside of the blockchain world, then other blockchain primitives like crypto attestations will have a better chance of succeeding too in the outside world, since they are easily composable with each other. Number 8. Open source AI with incentives. Another thing at which blockchain is very good is at creating financial incentives for people to make them contribute their effort or work to collective projects. In that sense, blockchains could be a great incentive layer for open source AI. Open source AI is doing a great service for humanity, at least for now, but that doesn't mean that the people who create it don't also deserve a financial reward. Also, financial rewards attract even more talent. For example, developers who are more hard-pressed for money and who under normal circumstances wouldn't be able to spend their time on non-profit activities. Blockchains allow easy creation of networks in which the target activity is incentivized via a token. A token that will accrue in value as the network gets more users and contributors and attracts more investor interest. There are a large number of ways in which blockchains can create incentivization for AI. One example would be allowing people to share their own data with data pools for model training. Another example is model development. Actually, right now, the most popular project of incentivized AI is BitTensor. BitTensor is also dubbed the Bitcoin of machine learning because it is similar to Bitcoin in that their currency, Tau, is also capped at 21 million coins. And in that to mine one of those coins, you have to do some work in exchange. But in this case, the computer work that people do to obtain the coins is used for developing AI models. Antithesis 1. Crypto tokens are not backed by anything real. They are a scam. Well, this objection is easy to counter because regular money like US dollars are not backed by anything either, and yet people work and kill for them. Regular money and crypto money both are now just relying on user confidence. When enough people have confidence in a nation state or a crypto network, like for example Bitcoin, its currency becomes successful. When not enough people do, that currency crashes, like for example the Argentinian peso. Antithesis 2. These incentivization schemes are far too confusing to attract enough participants. Regarding this objection, I have to agree that this is also one of the things that I find most frustrating about crypto projects. Boy, are they convoluted. I don't mean all of them are. Some of the best exceptions have a very elegant and simple value proposition, but many are so confusing that I think they scare people away or contribute to that perception that crypto projects hide a lack of strong value proposition behind a lot of fluff and gratuitous complexity. Tensor is one of those famously complex projects. Marketplace, mining, competition, cooperation, training, inference, subnets. BitTensor certainly doesn't pass the elevator test. But in BitTensor defense, we can also say that it is attracting interest from key players from the broader AI open source community. People who don't have a vested interest in hyping crypto because they are not from crypto, like for example Nose Research or the CEO of Hugging Face. Number 9. ZKML. This ZKML use case doesn't only require blockchain, but also other sister cryptographic techniques like zero-knowledge proofs. However, many of these hybrid solutions are being explored by developers from the blockchain community and integrated into products that also leverage blockchain. So that's why I've included this item on the list. To characterize the full scope of this use case, we should probably use some long name like verifiable and privacy-preserving AI. But in practice, you will simply hear people refer to it as ZKML, Zero Knowledge Machine Learning. That's because zero knowledge is one of the most important cryptographic techniques used in this area. But there are many others that are also used, like homomorphic encryption, multiparty computation, and of course, blockchain. At present, the main potential applications of this emerging field are privacy-preserving inference, sending encrypted queries to AI models so that whoever owns that model can read neither your query nor the encrypted answer the model returns. IP-preserving inference. This is the opposite. This allows for people to share their model for other people to do inference, but without revealing the underlying model that remains protected. An example use case is a machine learning bounty in which participants can send their models to compete without risking having their model's intellectual property stolen. Verifiable inference. This is for applications that require an unforgeable proof that a specific model version was used to provide a specific answer. This could be a common request in the future when some high-stake decisions will be made based on decision-making powered by AI. For example, decisions that affect large amounts of money, or doctors' surgical decisions, or any other decisions with legal liability. At that point, certain specific vetted versions of AI models may be whitelisted for these critical applications, and an unforgeable proof of their use will be required. Privacy-preserving training or fine-tuning. This will allow you to train or to fine-tune a model with encrypted data. For example, people can contribute their genetic or other medical data to a dataset that will be used to train a diagnosis AI without exposing all that very personal information. Antithesis. This is a solution looking for a problem. The majority of end users don't care enough about privacy-preserving AI. In the same way that people currently trust corporations to not spy on their phone calls or on the data they store on their clouds, they will also trust them to perform AI queries and model fine-tuning on their clouds. After all, corporations have a strong incentive not to breach the terms in their privacy policies to avoid serious legal and PR repercussions. Okay, this objection has a point. People often misunderstand the limited real access that corporations have to their private communications. But even if a corporation is not voluntarily breaching their client's privacy, sometimes catastrophic accidents or hacks can happen. An example, recently a hacking attack on the genetic testing company 23andMe exposed information from more than 6 million customers. Soon, we will all be submitting our most intimate information, our entire genome, to medical AI models to have them design personalized treatments and drugs for us. So having systems that possess built-in privacy could become much more necessary when the privacy stakes get so high. Number 10. Smart contracts. I often think that blockchain smart contracts should instead be called automatic contracts. Smart is a bit of a misnomer that's making people confused because smart contracts have no cognitive abilities whatsoever. Smart contracts are just a bunch of deterministic code that define very strict conditions and outcomes. If this and that happens, then do that. But this could change soon. If a damn smart contract could make a call to an external AI model, then smart contracts could actually start to truly become intelligent smart contracts. For example, a smart contract for a music competition. You could create an on-chain music competition in which a smart contract will not only keep the prize money in escrow, but also select the winner by using an AI model specialized in musical analysis. When the smart contract needs to make the judgment, it will trigger an external call to that music AI model. This is a beautiful example of AI and crypto supplementing each other. AI provides the cognition to make the non-deterministic decisions, while the blockchain offers a perfectly transparent, tamper-proof platform in which the money can be stored and the participants recorded, and that will automatically execute the price payments when all the conditions are fulfilled. Antithesis. The problem is that oftentimes smart contracts are used for very sensitive decisions that can affect the issuance or transfer of massive amounts of money. Very few blockchain protocols will trust a contract making a simple API call to some external model to make such critical decisions. This is a reasonable objection, and in many critical blockchain applications, blockchain will need to be supplemented with other technologies like zero-knowledge proofs that, as we saw earlier, can create unforgeable proofs that a certain vetted model has really produced the inference that is going to be used by the smart contract to execute that critical outcome. Number 11, human-free DAOs. A DAO is any type of for-profit or non-profit organization that runs on top of a blockchain. Traditional organizations are prone to corruption and nepotism because humans are very easy to corrupt by third parties or by pursuing their own selfish agendas in detriment of the common interests of the organization. Now, blockchain DAOs partly solve that corruptibility problem of organizations by leveraging two things. One, the radical transparency of blockchains, and two, the enforced automation that blockchains facilitate, the smart contracts. Actually, it is often said that the blockchain replaces laws and regulations with self-enforcing code. However, as we just saw, smart contracts were, at least until very recently, just dumb contracts. And so any part of the day-to-day of running the DAO that required complex decision-making still required a human making that decision. As a result, even the most successful and automated of DAOs still have humans in the loop, and the potential for corruption that comes with us. And that's why intelligent smart contracts, by eliminating the need for human discretion, could also help realize the dream of the fully incorruptible DAO. Antithesis. AI may not have self-interest for now, but it is still not purely objective due to bias and can also malfunction due to hallucinations. So if it is dangerous to connect just one smart contract to an external AI decision maker, imagine leaving the entire fate of an organization in hands of external AI models. Once again, I think this objection makes a lot of sense. A hallucinating model could lead to disastrous outcomes, or even worse, bad actors could study an AI model to find a way to exploit its weaknesses and carry out an adversarial machine learning attack to hijack the DAO's decision making. Actually, Vitalik recently defined this dilemma rather eloquently. If an AI model that plays a key role in a mechanism is closed, you can't verify its inner workings, and so it's no better than a centralized application. If the AI model is open, then an attacker can download and simulate it locally and design heavily optimized attacks to trick the model, which they can then replay on the live network. Number 13. Post-scarcity-resistant. The fourth industrial revolution will finally automate the remaining jobs that the previous industrial revolutions couldn't mechanize. As we approach AGI, advanced AI will start to replace all those white-collar jobs that today are still needed to run factories and other industrial, mining, and agricultural operations. At the same time, AI-powered robots will start to automate the blue-collar jobs that until today are still needed inside factories, warehouses, transport systems, etc. This ultra-automation, together with the acceleration of technological and scientific discovery that is going to be facilitated by near AGI and post-AGI synthetic intelligence, will bring the cost of most goods and services down to negligible levels. In such a post-scarcity society, the value of the few goods that we can't make more of will skyrocket, because more and more of our available purchasing power will move from other places to concentrate on those still scarce assets. I love to give the example of land, because it's very easy to visualize. No matter how smart and how skillful our AI and robotics industrial complex gets, you just can't produce more Earth's surface. And another category of goods that is also post-scarcity resistant are those whose scarcity comes from consensus instead of physical limits. In my book, The AI Rider, I call them socially scarcitized assets. This can be physical, like physical art. For example, a Van Gogh is valuable no matter how good AI-powered manufacture gets, because the value of a Van Gogh comes from the aesthetic and cultural consensus of humans, or at least of a significantly large group of humans. But socially scarcitized assets can also be digital, like digital art. For example, Beeple artworks, just like Van Gogh artworks, sell for a lot of money not because there's anything inherently scarce about them, but because a sufficiently large group of human tastemakers and human investors agree that they are valuable. The only difference between digital art and physical art is that digital art is easily copyable, and there's no one copy that can be considered the original. Blockchain tech, particularly NFTs, are the best method we've found so far to express the ownership of a piece of digital art in a way that can be considered unique and therefore scarce. Antithesis. The common objection here is a plain and simple: NFTs are a scam. In fact, if the blockchain has produced one thing that is even more hated than cryptocurrencies, that thing is NFTs. There are good reasons for it. The concept is a bit too abstract. An NFT is not the actual art. You are just buying a certificate that represents the official ownership of that art, but the art itself anyone can copy and reproduce. You've heard the tune. But there is also a great anti-antithesis, and it is the example of photography. Photography has exactly the same problem as digital art. There's nothing that can be considered the original. You can potentially make infinite prints of a photograph. Despite that, even before the creation of NFTs, limited editions of photographs have been selling for tens, hundreds, or even millions of dollars, just out of pure social consensus that they represent the underlying artistic value of the copyable work. AI and the post-labor society are going to have us spend more and more time indulging in entertainment. And a lot of it will be spent in immersive video games and other metaversial virtual places. Over time, more and more of the digital assets that are present in those worlds will acquire symbolic, cultural, or even practical value, and the blockchain is for now the best method of recording and transferring their ownership in a transparent and secure way. Number 13. Fully on-chain intelligence. Connecting blockchains to external AI models and using ZK proofs to offer guarantees of that connection could be enough to integrate the advanced cognition that AI offers into blockchain markets and blockchain organizations. But the ultimate convergence would be to run entire AI models natively on the blockchain itself. So far, the only blockchain I found that claims that they can run entire AI models completely on-chain is Internet Computer. Antithesis: running entire models on-chain will never be feasible or practical. The reason is that the special advantages of blockchain computing, decentralization, consensus, immutable historical record, and so on, are possible thanks to a big trade-off. Computing anything on a blockchain is slower and more expensive than doing it on a traditional computing architecture. I have to admit that I don't know how accurate the claims of the Internet Computer project are, because once again, digging deep into the many technicalities of such a complex blockchain architecture would require research for an entire other video. But even they admit that for the largest AI models, this is still not possible, and that their blockchain can only run the smaller ones. Anyway, if you are a big Internet Computer expert and can tell me more about it, please DM me on Twitter or leave a message here. Number 14. UBI and AGI Endgame. Okay, so let's end with a bang. You already know that the most powerful man in AI has his own crypto project. But what very few people in crypto are aware of is the full scope of Sam Altman's endgame for that project. This is in part because Altman and the World ID team mostly focus on the use case of fighting human impersonating AI when they give interviews, and they only mention very briefly the other use cases, if at all. I think that perhaps they do that to not look over-ambitious or to scare authorities. The thing is that Sam Altman, like anyone who is working towards achieving AGI, knows that AGI is the end of work. AGI and AGI-powered robotics will be able to do any physical or intellectual job that humans do, only better. And this will require a complete redesign of our economic system, one that is based on sharing all the immense wealth that the AGI robotic industrial complex generates with barely any human intervention. That's why the network they are building to give every human on Earth an unforgettable way to prove that they are human will also be used if the project succeeds, for two more things for which blockchains are perfectly suited. One, the blockchain will be used to distribute the wealth generated by the AI robotic industrial complex among all of humanity. One human, one piece of the pie. Two, the blockchain will be used to govern AGI in a democratic way. One human, one vote. How's that for ambitious goals? But in truth, the blockchain really is the best computing platform that humanity has invented to exchange value, in this case UBI, and to coordinate people, in this case AGI governance voting. Because the blockchain has built-in radical transparency and built-in tamper-proofness. The problem is that any blockchain project that tries to distribute cash among humans or to allow humans to vote would be met with unending civil attacks made by people faking humans to get more than one share of the pie or more than one vote. That's why the first primitive for making such a project possible is to create a network of true, unique humans. Antithesis. This use case is clearly the most far away from being realized on this list, and so there's plenty of things that could be included as an objection. There are not only technological obstacles, but enormous legal, political, geopolitical obstacles. Many stakeholders, and what's even more difficult, many nations would need to come together to fully realize this use case. We are really almost in the realm of political science fiction here. Also, if OpenAI continues to lead the race towards AGI, and if Sam Altman continues to be the head of OpenAI when AGI is achieved, it will be much easier that his vision for World ID could be realized. But if some other company, institution, or nation gets to AGI first, or if AGI gets achieved via open source, or if many AGIs are achieved and compete at the same time, then the bargaining power of Sam Altman will be reduced. But at the end of the day, even if World ID fails, the blockchain could still be used as the UBI payment rails and as the AGI governance layer, because as we've seen, it offers great technical advantages for both. So that's all for today. I hope you found this video useful. And by the way, in this video, I took for granted some things about AI that many may still find controversial, like the claim that AI is the biggest invention in human history, or the claim that AGI will be the end of human work. So if you're curious about why this is the case, I've written a book explaining it. It's called The AI Rider. It's available on Amazon, and it explains our current AI revolution, but in a very big picture, zoom out kind of way. So I'm leaving a link in the description. However, I will also create a video at some point completely ripping my book off, so you don't need to buy it if you prefer your information in video format. Well, thanks so much for watching this crazy long video. Give me a like if you liked it, and see you soon.